section, we're going to solve exponential and logarithmic equations. Now, let's think back whenever we were working through our exponentials previously. What was the goal? What did we want? Like bases. Good. So anytime you have an exponential equation, your goal for that exponential is always to get those like bases. Now, if you can't get like bases, then this is where we're going from here. Notice on this one, I have 7 to the x and 12. So there's no possible way for me to get like bases. And this is why we had to study logarithms. Because remember, inverses are the logarithm and the exponential are inverses of each other. So in order to get that x down, I need to take the natural log of both sides. When you do that, you can now use your logarithmic properties, and we have that power property where we can bring that x all the way in front. So I now actually have x, natural logs of 7, is equal to the natural log of 12. My goal anytime I solve an equation ever is always to get that x by itself, so I'm going to divide both sides by that natural log of 7. I now have x is equal to the natural log of 12 divided by the natural log of 7. And this is where your calculator comes in, because on these particular problems you want to look and see for your calculator. If you have a Texas Instrument, it's going to put, most of them except the new ones, is going to put parentheses around what you put into that natural log. You will also need to put a set of parentheses around the numerator and around the denominator. Now these single ones, it's really not that bad. So if you lose the blue set of parentheses right now, not that big of a deal. Will be a bigger deal later, but for now, it's not that big of a deal. And then your book will tell you which decimal place to round to. For this one, if you plug that in, you should end up with 1.277. And that'll be your answer. So your homework will tell you which decimal place to round to, and then you can go from there. Cool, let's do some more. Now for this one, it gets a little spicy, which honestly is not that big of a deal, but it's just a matter of chugging it out. So when you look at this problem, notice, again, my goal is to get like bases. There's no possible way for me to make 3 and 0.4 have like bases. So if you can't make like bases, that's when you take the natural log of both sides. So I'm going to take the natural log of 3 to the 2x minus 1 is equal to the natural log of 0.4 to the x plus 2 power. And that's when we take this exponent and bring it in front. Now the deal with this exponent is the fact that it's a binomial. So whenever I put this exponent in front, we need to put parentheses around it. So I have 2x minus 1 times the natural log of 3 is equal to this x plus 2 times the natural log of 0.4. Now the kicker to this problem is the fact that you have an x in those parentheses. Now, natural log of 3, here, this number, and the natural log of 0.4, those are literally just numbers. If you type that into your calculator, it'll give you a number. So those are just numbers. It may look a little freaky. It's not so bad. It's just a number. So I'm going to take this number and distribute it to my parentheses. So I now have 2x natural logs of 3 minus 1 natural log of 3 equals x natural log of 0.4 plus 2 natural logs of 0.4. And the whole purpose of doing that is so that I can get this x out of parenthesis, this x out of parenthesis. Remember, when you solve an equation, the goal is always to get x by itself. So that means I'm going to subtract this x natural log of 0.4 from both sides so that I can get my x's together. And I'm going to add the natural log of 3 so that I can get my numbers together. Now, because these are not like terms, then you can't put those together, so we just have to rewrite it. So I have 2x natural logs of 3 minus x natural logs of 0.4 equals 2 natural logs of 0.4 plus the natural log of 3. All I've done here is I've rewritten these two to be on the left. I've rewritten these two to be on the right. Now I know it looks a little freaky. I totally get that. But that's what your calculator is for. Don't get caught up in the freakness. Just put the x's together, put the numbers together. That's your goal. The whole purpose of doing that is now I can look at the terms on the left, see that there's an x in common with both of them, and factor that out. So if I factor an x out of the first term, I'm just left now with 2 natural logs of 3. This x is factored out. I factor an x out of the second term, and I'm just left with a minus natural log of 0.4. Equals, I haven't done anything to the right side, so we just rewrite that. Now that I have that x factored out, I'm going to divide by 2 natural logs of 3 minus the natural log of 0.4 divided by 2 natural logs of 3 minus the natural log of 0.4. This value on the right side is now your exact value. These cancel out and I have x left on the left side. Now here's the kicker, and it comes to the calculator. Because of that plus sign, you are going to need parentheses around your entire numerator and your entire denominator. Keeping in mind on certain calculators, they put the parentheses around what's inside of that natural log. So at the end of this parenthesis, you're going to type in parenthesis 2 natural log parenthesis 0.4, close that set of parentheses, plus the natural log of 3 in your parentheses. Make sure you put a double parenthesis at the end before you write your division bar. All right? Then set of parentheses 2 natural log of 3, close it, minus the natural log of 0.4, double parenthesis at the end. And then whenever you click enter, then you can come up with approximately negative, it's a negative number, negative 0.236. And that's your approximate answer. Don't get hung up in how freaky it looks. Go ahead and just work it out, and then the biggest deal on this one is putting it in your calculator. Now, if you have this part somewhere on your paper, you will get credit for that. You are going to have to be able to put it in your calculator, which is why we'll practice that in class. However, if that is on your paper, it's always worth showing your work because that's the real deal there. I want to make sure you can plug it in your calculator, but I more importantly want to make sure that you can do the work. Cool. Let's try another one. Now, here's the deal. Anytime you see an exponential like that natural e to the x, you automatically think natural log because they cancel out. Anytime you see the natural log, you automatically think e because they cancel out. Those are inverses of each other. So in this instance, because I have this e x squared, then I'm thinking natural log. So whenever you take the natural log of both sides, that. Now remember, anytime natural log and e are touching, they cancel out. So natural log and e are inverses of each other. So anytime you can get them to touch, that is when they cancel out. So if those cancel out, I'm now left with x squared is equal to the natural log of 200. Now we've solved quadratics, we're just going to use our square root property. Anytime you physically make the square root symbol, what do you have to write? Plus or minus, you got it. X is now equal to plus or minus the square root of the natural log of 200. And that's the deal. So if I'm looking at these answers, X is now equal to plus or minus the square root of the natural log of 200. If they ask you to round your answer, that's going to be plus or minus 2.302. So you actually have two answers, a positive and a negative. All right? Cool. Great job.